All right. So the last little set of directions say, find K such that the given equation, or the line that's given, is tangent to the equation. EQN, equation, so before anybody asks, and I have to say shut up. So, find K such that the line is tangent to this given equation. So I have the function is K minus X squared, and the equation of the tangent line is Y equals negative 6X plus 1. Now, what is going through your mind with this tangent line that's given? Somebody tell me what that is.
That's the slope.
That's the slope. What is the slope of the tangent line? The same as the derivative. So here's my thought. I'm going to take the derivative and set it equal to that negative 6. Does that make sense? Take the derivative. You can do it. Derivative of a constant is just 0, right? What's the derivative of minus x squared?
Minus 2.
Plus 2.
Minus 2x.
Isn't it plus? No, yeah, never mind. I was thinking.
So I'm going to say negative 2x must equal negative 6. I now know what the point of tangency is.
X equals 3.
Or at least the x value, right?
And then you plug it into the original.
They want to know what the k is, though.
Isn't the K just what?
I know the x value of the point of tangency. I know the slope was negative 6. But I still can't figure out what that k is.
You find
Yet.
the Y value.
You find the y value. Does it make sense that the y value of the equation of the tangent line would have to equal the y value on the function at that point? Because the tangent line does intersect the function at that point, right? At the point where x equals 3. So if I figure out what the y value is at x equals 3, I'll have it. Negative 18 plus 1 is, now I know what the y value is, which is the same as the f of x value, right? Negative 17 equals k minus, what was 3 squared? Everybody with me? Plus 9. What does my k equal? Negative 8.
Beautiful.
So that is just, in terms of thought processes, that is just one extra step, isn't it? To think, oh, well, the y values must be the same. One more example and we'll be done.
Don't have that much space.
Well, then just pay attention if you want to. How about f of x equals k square root of x? It is the same thought process. I'm just making sure you get that in there. The slope of this tangent line is 1, or f prime of x would have to equal that 1, correct? What is f prime of, oh, do we need to do a little rewrite here? K x to the 1/2. Remember, k is just a coefficient, treated like a constant, right? How do we take the derivative? Or 1/2 k x to the
Negative
1. So, oh, this is a little weird. I got a k on top, a 2 squared of x on the bottom. Is that what you're seeing? Uh-oh. this thought process is not exactly the same because I have one equation with two variables. How do I get the second equation?
No. Well, you could.
It's the same thought process. We're gonna say, well, won't the y values equal each other? So that's how we turn this into a system, not a piecewise, a system of equations. The issue is how to solve it. Because I know it's k that I'm ultimately looking for, and I really don't care what the x value is, I'm thinking multiply both sides by square root of x. This is like not my normal go-to on systems is elimination, if you remember. But I'm going to say I'm not going to use elimination. I'm going to use substitution. I have something for equation 2 to substitute in for that square root of x. What would it be?
K square root of K divided by 2.
No, just k over 2, right? Square root of x equals k over 2.
Oh, yeah.
I'm substituting directly. But I also have a regular x. How would I solve for a regular x here?
X squared.
You'd square both sides, right? So x would equal k squared over 4. Now we can get somewhere. K squared over 2. Any suggestions?
No.
Subtract the k squared over 4 to get it to the left. Common denominator. Need to multiply by 2. What is 2k squared over 4 minus 1k squared over 4? 1k squared over 4, right? Next step. We're solving for the k squared. It's being divided by 4. What do we do? Multiply by 4. K squared equals 16. K either equals plus or minus 4. Well, could it be negative 4?
No.
I mean,
Yes.
maybe.
No.
I don't know if we should figure out, the problem is when you square both sides, sometimes it gives you an extra answer. So now I'm feeling like we got to go in and plug it in for the x. So positive 4 over 2 root x equals 1 would make the square root of x equal to 2, square root of x equal to 4. Could it happen if I tried negative 4 for the k over 2 root x equals 1? Square root of x, oh, well there it is. Can you have a square root to be a negative number?
Yes.
No, yeah. So I'm going to say negative 4 has got to be out. K only equals 4. So that is our thought process. In the first problem, we didn't have to do a system. We just had to think of setting the y's equal to each other. The second type is you might have two variables, so you have to have two equations.